Bismillahirrahmanirrahim. Welcome to my new class. So today the topic which I am going to present, that is related to pharmacokinetics. So what is pharmacokinetic? Pharmacokinetic can be defined as the study of what the body does to the drug. So it means pharmacokinetics mean it is the study how the drug is absorbed, distributed, metabolized, and it can be excreted from the body in the form of metabolism. So you can say that what the body does to the drug. Pharmacokinetic, in another word, it can be defined as it is the study of absorption of drug, distribution of drug, metabolism of drug, and excretion of drug from the body. It means that how the drug is absorbed, and then how it can be distributed, and then how the drug can be metabolized, and what are the pathways through which this drug is metabolized. And the simple formula is ADME. So this is simple: absorptions, distribution, metabolisms, and excretion. Now where the absorption will be take place, where distribution will be occur, where metabolism, so inshallah it will be discussed onwards. Now pharmacokinetic, it is divided into 4 parts, and pharmacokinetics, the first part, that is absorptions, how the drug is absorbed. So absorption can be defined as that how the drug is moved into the blood from the site of administrations. So it means when we are going to administer a drug, so how this drug will move across into the blood after administration. After administration, the drug will move across, or the drug will move into the bloods. So this is clear. It means that, let's suppose if we are going to administer a drug orally, sublingually, or it may be any form like orally, so it can be directly administered, and after administration it will be directly move into the bloods, and then it will be absorbed. Now how the absorption is, the second one is distributions. Distribution mean that how much the drug is moved to various body tissues or organ depend upon on the blood flow through tissue. This is called distributions. The third one is metabolism. Now what is metabolism? So as we have discussed in biochemistry, that metabolism, how the drug is altered, broken down. So metabolism is, we know that the drug, whenever, so let's suppose if whenever the large particles, so they are broken down and they are converted into smaller particles. So in metabolism of drugs mean that the drug must be metabolized in the liver before it's reaching to its stomach circulation. It means that during metabolism there will be anabolism and catabolism reaction will take place. The drug will degrade, the drug will alter, and the drug will broken down. So after that, excretion mean how much the drug is, how much the quantity of a drug, the amount of the drug which can be excreted or removed from the body. Now look at here, this is absorptions. Absorption mean this is called site of administration, this is drug, and this is what, biological barrier, and this is vascular system. It means that after administration of drug, the drug will be absorbed, and there is a biological barriers. So you can say the absorptions, it may be slow or it may be fast. So it depend, and then it depend upon on the condition, then it depend upon on the nature of the drug. Let's suppose you are going to administer oral drug, so the absorption of oral drug, it will be definitely slow as compared to the parentals, as compared to the injectable. Let's suppose you are going to administer a drug in the form of injection, so definitely, so its absorption will be fast. Now look at here how drug absorption is occur. So drug absorption of various dosage form. Now here in this case, which one of the following drug they are quickly absorbed, or which one of the following drug is slowly absorbed. So all these are oral preparations. These are liquids, elixir, and syrup. So the liquids, elixir, and syrup, so it is fastest absorptions. Now and second category is suspension or solution, so they are also, you can say, past test. And now after that the powders, then capsule, then tablets, then coated tablet, then anti-coated tablets, so there's lowest. Now this is called order of absorption, that how which one of the following drug they are absorbed quickly, or which one of the following drug is absorbed. So it means that the absorption rate of liquid, elixir, syrup, so they are greater than suspension and solutions, and then the absorption rate of suspension and solutions as compared to the powder, and then capsule, and then tablet, and then coated tablet, and then anti-coated tablet, so its absorption is slow. So here we are talking about the drug absorptions which are taken orally. So if we compares the oral preparations and injectable preparations, so its rates of absorption will be automatically different from one another. So it also depends upon on the nature of the drug. So I will inshallah discuss in detail. This is called IV route. So what would the graph of the blood level against time look like? You look at here, this is the blood level and this is the time, and these are the peaks. So what does it mean? It means that this is the graphical representations. It means that whenever you are going to administer a drug by IV route, so it means that it has, you can say, 100% bioavailability, and that drug is quickly absorbed. So its peaks, they are higher. Now look at here, this is oral route. So what would the graph of the blood level against the time look like? So this is, you can say, this is blood level, and look at here, this is time. So look at the peak. So it means that whenever you are going to recommend it, whenever we are going to let's suppose administer a drug orally, so definitely it would take a long time to absorb. So here look at the difference. This is IV route. These are the peaks which are obtained after mean absorption after administration of any drug. So it means, look at the difference between IV route, and this is the graph. This is the graphical representation of IV route, and this one is the graphical representation of oral route. So you can easily differentiate between oral and IV route. Now what is happening in these two phases? This is blood level. In the same case, this is time. So what is this and this one? This is these red lines and this line. So you can see here, this means absorption and distributions. This is what this shows, the absorption and distribution, and these lines show the metabolism and excretions. Now come toward bioavailability. What is bioavailability in pharmacology? Bioavailability can be defined as it is the fraction of administered dose of drug that reaches to the systemic circulations. It can be defined as, there are different definitions. By mean life, and available mean that how much the quantity or the amount of drug which is administered, the dose of the drug, you can say the quantity or the amount of drug which is available, which are available for general systemic circulation, that can be reached to general systemic circulations and unchanged form. So this is correct definition that you can easily define is that it is the fractions of administered dose of a drug that reaches to the systemic circulation in the unchanged form. Let's suppose they have mentioned here that the bioavailability of IV route is 100%. So it means how? Look at here. This is the classical example of bioavailability. So once again, bioavailability is the fraction of administered drug that reaches to the systemic circulation. For example, let's suppose if 100 milligram of a drug they are administered orally, and 70 milligram of this drug they are absorbed and unchanged, so the bioavailability is 0.7, or you can say 70%. So from this example, bioavailability is clear that if, let's suppose if you have 100 milligram drug and it can be administered orally, and 70 milligram of the drug they are absorbed, while 30% milligrams while 30% drugs, so they are, it means that 70% of the drug they are excreted from your body in the form of sweat, in the form of urine, and the form of waste materials and anything. So the 70 milligram of the drug they are absorbed in unchanged forms. So it means that 70 milligram drug they are capable to perform some pharmacological activity. Then the bioavailability of that drug is 0.7 or 70%. So this point is clear. Now what are the factors that influencing the bioavailability? I means that these are the factors which may directly or indirectly affect the bioavailability of the drug. Let's suppose it depend upon on the dosage form. It means, let's suppose if you have if you have two dosage form, one is solid and the second one is liquid and the third one is injectable, so it means there must be a little bit difference. It must be different in its bioavailability. So it means that, let's suppose if you are going to change the natures of the dosage form, the shape of dosage form, so it may directly or indirectly affect the bioavailability of that drug. Chemical form, so it can also influence the bioavailability. So it also depends upon the chemical nature of the drug, while dissolution and absorption of drug. Okay. So bioavailability, these are the different factors which may directly and indirectly influence the bioavailability of a drug. Let's suppose dissolution and absorption of drug. There are some drugs which are slowly absorbed, while some drugs they are quickly absorbed, while dissolutions through which we can check the bioavailability of the drug. So routes of administration of drugs. So this is also very important that let's suppose if you are going to administer a drug by oral route or by sublingual route or by injectable route, so definitely its bioavailability will be different from one another. And the bioavailability, it can also affected by the presence of food and drugs and GI tract. So pharmacologically, let's suppose on empty stomach the absorption of drug will be increased, while on full stomach the absorption of drug will be decreased. So that's why, so ultimately the bioavailability of the drug will be affected. So the presence of food or the drugs and the GIT, it may also influencing the bioavailability of the drug. Pass effect, so it is also one of the major contributing factor. So first pass effect means the drug, as we know that the liver, this is the major organ which is responsible for the drug metabolism or for the food metabolism. So first pass effect can be defined as all the drug, it must be metabolized in the liver before it's reaching to its systemic circulation. So then I will explain the pass effect in detail, but actually here the pass effect, this is the only factor that influencing the bioavailability. So let's suppose a person who is suffering from liver function, who is suffering from liver dysfunctions. So it means that and liver is responsible for the metabolism. So in that case, definitely the bioavailability of the drug will be affected, because as we have already, this point is clear that all the drug and food that must be metabolized in the liver before it's reaching to its systemic circulation. And in other words, it can be defined as the extent of the drug metabolism before reaching to systemic circulation. So it means that all these factors, these are the contributing factors which may directly or indirectly influence and affect the bioavailability of the drug. And inshallah in my next lecture, so I will explain the different technical terms which are used in pharmacology. Inshallah it will be discussed in detail. Thank you so much.